All right, so example 3 for section 7.4, we're going to go through our 4-step process that was outlined on the previous page, and we are going to find and interpret a confidence interval. So the Kaiser Health Tracking Poll surveyed 1,504 American adults and asked them if they supported the requirement that private health insurance plans cover the full cost of birth control. The poll found that 61% of the respondents supported this requirement. Find a 95% confidence interval for the percentage of all Americans who support this requirement. All right, so the first thing we're going to do is we are going to start by listing out what we know, what we want to know, checking our conditions. So again, these first few steps should look very, very familiar to the last section. All right, so N, our population, capital N, is all American adults. Lowercase n is the 1,504 American adults that were sampled. P hat is our sample proportion. So in this sample, the poll found 61%. Okay. We're told to find a 95% confidence interval. So our confidence level is 95%. And then what do we want to know? Well, we want to know the confidence interval. Right, and our confidence interval, just as we saw in our first couple of examples, is going to be p hat plus or minus m. The big difference here, instead of being given m, that is going to be the first thing that we are going to be looking for, one of the things that we are going to be looking for. All right, so step 1, we want to check our conditions of our central limit theorem. The sample is random and independent. We are going to say yes, that is. That we have a large sample, at least 10 successes and 10 failures. So we're going to take our sample size. So our sample size is 1,504 times our sample proportion is 0.61. If these don't work out evenly and you need to do some rounding, just make sure you round appropriately. This is going to give us 917, which is equal to 10. Right, and then we're going to check our failures. So 1,504 times 1 minus 0.61. That gives us 587, which is also larger than 10. Now, before we go on and we check our last condition, I do want to mention just kind of one thing briefly. And just kind of highlight this, because as we are using StatCrunch, if you do choose to go through and talk about these problems using StatCrunch, there's only going to be 2 pieces of information that you are going to enter. You are going to be entering your sample size, and you are going to be entering your number of successes. So in that case, our sample size is 1,504. So that would be one value that we would be entering if we were using StatCrunch. And then our number of successes is our X value. So in that case, this 917 that we get here would be the other value that we would be entering in StatCrunch as our X value. So just kind of a little note here that these 2 highlighted values are the ones that we're going to use in StatCrunch when we're going through and we're using the problems that way rather than calculating them by hand. So again, the stuff in the green here is our values for StatCrunch. Again, we'll talk more about that in class, and there will be an additional PDF that's posted for that as well. All right, so going back to checking our conditions, our large population, right, our population is all American adults. Right, we take 10 times 1,504, we get 15,040, right? And there are definitely more than 15,000 American adults. So our sample size is large enough from condition 2, and then our population size is large enough from condition 3. So our conditions have been met, so we can go ahead and continue on with our problem. All right, so step 2, we're going to find our standard error estimate. If we look back up here, again, we're going to use our p hat and our n that we've been using in this formula. So we plug these values in here. 0.61 times 1 minus 0.61 divided by n, which was that 1504. Again, if you're plugging this into the calculator, I recommend plugging in as much in it as once. Wait until the end to round, and we get 0.013. As we did before, a lot of times we're going to round our standard error estimate to 3 decimal values. All right, step 3, we're going to find our margin of error. So we're going to take our z star times SE, our standard error. So we go back to our table. Again, we're using this little table on page 24. And we were told in this particular problem that we were using a confidence level of 95%. So we're going to be using a z star of 1.96. And as we go through the rest of the examples, we are going to keep referring back to this table on page 24. So this is something that, again, you want to make a note of, put a bookmark, put it on an index card, post it, something along those lines. So z star times our standard error, we're going to take 1.96 times 0.013, and that is going to give us 0.025. So our margin of error is 2.5%, right? If we change it back to a percent. To find our p hat plus or minus m for our confidence interval, we're going to take our p hat value, which was 0.61, plus or minus 0.025. Again, we subtract first and then we add. So 0.61 minus 0.025, comma 0.61 plus 0.025, and that gives us an interval of 0.585 to 0.635. All right, so that's finding our interval. Cut off just a little bit there. All right, so there is our confidence interval. All right, now we're going to interpret that. And in our interpretations, remember, we always start with our confidence level. And just for room's sake, I'm going to put that information up here. So we're going to start and we're going to say we are 95% confident. Right? And then we start talking about our proportion that is in question. So we'll say we are 95% confident that the proportion of American adults who believe private health insurance should cover should cover the full cost is between. Okay, we're going to take those numbers from our interval and change those back to percents. So 58.5% and 63.5%. So again, as we're working through, we start by checking our conditions. Once we check our conditions, we find our standard error. We use our standard error to find our margin of error. We use our margin of error to then find our interval. And then we finish this off with an interpretation of our interval, which includes our confidence level, right? The proportion that we are looking at and the population that it's coming from. So in this case, the proportion of American adults who believe that private health care should cover the full cost. And then we finish it off by giving the range of values. And our range of values in this case, again, we change them back to percent, and we get between 58.5% and 63.5%.